Good morning, class. My name is Mr. Hall. I'll be teaching you today, and what we're going to review is the Pythagorean theorem, triples, and sine, cosine, and tangent. Now, don't worry, this may seem difficult, but I'm going to teach it faster to you than a freshman ditches his jewel when a teacher walks in the bathroom. So let's get started. Please excuse my camera as it may not like to focus. But first, let's start out with the Pythagorean theorem itself. The Pythagorean theorem is three sides of a right triangle to find the hypotenuse, or all three sides, the sum of all three sides, that is. So I have a couple slides here I'd like to go over. Let's start out. It has to be a right triangle as stated. So once you find the 90-degree angle, to find our hypotenuse, it's going to always be across from it. That's how you normally find our hypotenuse, or c squared in our sense. But how do we get the c squared? So right here we have a, b, and c. Those will be our variables for our main problem of the Pythagorean theorem. A squared plus b squared equals c squared. So let's look into an example. So with all of our knowledge together, we have this problem. 4 is our a squared, 3 is our b squared, and the question mark is what we're trying to find, or our c squared. So we have 4 squared, 3 squared equals c squared, 4 squared equals 16, 3 squared equals 9. So we're going to have, if you add these together, you'll get 25 equals c squared. Now the square root of 25 equals c squared, so c will equal 5. Now let's look at a different problem. So this time, we already have the hypotenuse, and we're looking for one of the legs. So if we take and look at it, we have a squared plus b squared equals c squared. We need to keep the same problem. It is very good knowledge. So what we need to do is 6 plus b squared equals 12. So we have to square those, making 36 plus b2 equals 144. You're going to minus your 36 from each side, making b squared equal 108. Now b squared equals square root of 108, which leads us to how we will get this final answer here. So we branch off to find how we will actually get our final result. So you don't have to do this. You can leave this answer how it is, or you can simplify it. So 2 and 54 make 108, 2 and 27 make 54, 3 and 9 make 27, 3 and 3 make 9, making our square root being 2 times 2 times 3 times 3 times 3, or 6 to the third, 3 squared. So that is how you start in doing your Pythagorean theorem, but let's look into something different, also known as our triples. There are many triples to memorize and know these are the triples. So if you have 3 and 4/5 here, these are a very good tool because they will, they will help. So let's make an example problem here. So we got a, b, and c. Excuse my handwriting. So we're going to make a squared plus b squared equals c squared. Now, if we had this problem and b was equal to 4 and a was equal to 3, we could use our triples to find out that c is most likely going to be 5. These are just a simple tool, so you don't have to do the math, and now we know that what our final answer is. You can use these on many different kinds. This is just kind of like a key or a rule bank, so you know what to look for. So if this was, say, 3 here was 6, b down here was 8, that would most likely mean that since our key here says 10, that our c would be equal to 10. Let's look into cosines, sines, and tangents. This is a little bit more difficult, but we'll get into it. So sine, also known as SOH. This, it's as listed down here, it's the opposite over the hypotenuse. So oppo will be our opposite, and hypo is our hypotenuse. This is the angle we're finding. This is why we use sine. So this is just one way to do it. This is the other way. And what it is that it's mostly the same problem with just different sides, because each side has a hypotenuse, an opposite, and an adjacent. So on our cosine, it's like our last problem, except it's hypothesis and adjacent. And it's adjacent over hypothesis, and that's how you figure out your cosines. as well as tangents. Tangents are opposites and adjacent, as shown adjacent and opposite, opposite and adjacent. That is how you find your angles for your cosine, your sine, and your tangent. Thank you for tuning in. I appreciate your attention.